In this video, we're going to look at writing polynomial models from zeros and additional information. The first thing that we want to talk about are complex zeros. Remember that you can have real zeros and complex zeros always come in conjugate pairs. So if we remember from Algebra 2, if I have a complex zero, something like 2 minus 3i, then the complex conjugate is going to be 2 plus 3i. So we always have to remember if we're given one complex zero, we automatically know that the complex conjugate is also a zero. So a lot of times they will tell you one complex zero but not give you the conjugate because you're supposed to know that. So let's look at the process that's going to be involved here. So we're going to determine all the zeros of the function. So they're going to tell you the real zeros and possibly a complex zero, and then you're going to need to remember to put that complex conjugate down as well. Then you're going to write the factored form for each zero, and the factored form is just going to be x minus your zero. Then if you have additional information, if they're given an additional point that's not a zero, you're going to plug that in for x and y to find your leading coefficient. If you need standard form, you're going to go ahead and multiply everything out. If they tell you the leading coefficient, you're just going to double check that and multiply through if you don't have the proper leading coefficient. So we're going to take a look at some examples here. So this first example is a cubic function, and it has zeros of 2, 1, and -3. So we're going to write this both in standard form and factored form. So we're always going to do factored form first. So we're going to have y equals, and then we would have a leading coefficient of a, and then each of my zeros, so x minus 2, x minus 1, and then x minus -3, which is going to give me x plus 3. Since they didn't tell us anything about our leading coefficient, we could put anything we want there. Typically, we just make that 1 and not make it any more complicated than that. So our answer would just be x minus 2, x minus 1, and x plus 3. You could put any number in for a that you want, and that would still be an acceptable answer, but typically they're looking for the simplest possible case. Also, we want to do the answer in standard form. So in standard form, we're just going to take that factored form, we're going to multiply it out. So you're just going to have to remember your algebra here. So we're just going to multiply these first two terms together, and I'm going to get x squared minus 3x plus 2. Then I'm going to multiply by that last factor, which is the x plus 3. So we're going to distribute there. We're going to get x cubed minus 3x squared plus 2x, and then plus 3x squared minus 9x, and then plus 6. So combining our like terms, we're going to get y equals x cubed. The plus 3x and the minus 3x will cancel out. We're going to have minus 7x, and then plus 6. We're just going to go ahead and graph that equation in standard form. So I have x cubed minus 7x plus 6. Go ahead and graph that, and then I can just check that my zeros are what was. So I'm going to go second, trace, and I'm going to do value. And then I'm just going to enter in the zeros that they gave me, 2, x equals 2, y equals 0. Then I'm going to put in the 1, y equals 0, and then I'm going to put in the -3, and y equals 0. So I'm confirmed that the answer I have is a correct answer. We'll come over here and look at another example. This says find the lowest degree polynomial in standard form with the following zeros. So again, remember we're going to start with factored form. So I'm going to start with y equals a times x minus 4, x plus 3, x minus I, and then remember this is a complex zero, so I also have -I. So we're going to do x plus I. To get to standard form, we're going to have to multiply all of this out. Again, remember, we want the simplest equation here, so we're just going to leave that as a 1. So I have x minus 4, I have x plus 3, and then when I multiply these out, I'm going to get x squared, and then I'm going to have plus xi minus xi, and then minus I squared. So when we simplify that, we've still got the x minus 4 and the x plus 3 here. We're going to end up with x squared, the xi and the negative xi cancel out. And then remember, I squared is equal to -1. So I have minus -1, which becomes plus 1. And then we can continue multiplying here. It doesn't matter what order we work in. I'm just going to multiply these first two together. So I'm going to get x squared minus x minus 12, and then times the x squared plus 1. Go up. So multiplying this out, we're going to get x to the 4th plus x squared minus x cubed minus x minus 12x squared minus 12. And then combining our terms, we got x to the 4th minus x cubed minus 11x squared. Should have been a cubed, sorry. Minus x, and then minus 12. Again, I'm going to use my calculator to double check my answer here. So I'm going to put in my equation, x to the 4th minus x cubed minus 11x squared minus x and minus 12. Remember that only your real zeros are going to show up on your graph, so we do have two imaginary zeros here, or complex zeros, so they're not going to show up on this graph. So I'm going to go second trace value at 4, y equals 0, and negative 3, y equals 0. So I can feel fairly confident in my answer because I know that my real zeros are showing up on the graph. This is an example that deals with a problem where they tell us what the leading coefficient should be. So we're going to start with this one with the zeros. I'm going to leave the leading coefficient out for a minute, and then we'll come back to that at the end. So here we've got a 0 of negative 3, so that's going to be x plus 3, multiplicity 2, so I'm going to write that twice. Then I've got x minus 1, and we've got x minus 1/3. The fraction is going to make things a little bit difficult, so we can manipulate that to make it easier for us as we multiply this out. So I'm going to leave the x plus 3 and the x plus 3 and the x minus 1. Then I'm just going to change this factor a little bit. I'm going to move the 3 in front of the x and make this 3x minus 1. Both of these terms here, if we set them equal to 0 and solve, are going to give us a 0 of 1/3, so we can use either one of them. Now I'm going to start multiplying out. So I'm going to multiply these first two terms together. Then I'm going to multiply the second two terms together. Now I just need to start to multiply these two factors together. So I'm going to distribute the x squared into the second parenthesis. Now I'm going to distribute the 6x into the second parenthesis. And finally, I'm going to distribute the 9 into the second parenthesis. Now we just need to combine our like terms. Now that I have my answer, I'm going to take a look at the graph to double check that, and then I'm going to check my zeros. So second trace value, I have a 0 at negative 3, y equals 0, and I can see that it's just touching the graph there, so it does have an even multiplicity. Then I have a 0 at 1/3, and I get y equals 0, and I have a 0 at 1, and I get y equals 0. So my graph confirms that my answer is a correct answer. If we go back to this, leading coefficient is 3. My answer does have a leading coefficient of 3, so that happened by us moving the fraction, the denominator of the fraction. So had we left that as the fraction and multiplied it out, we would have wanted to multiply by 3 at this point. But because we changed that, we kind of already had the answer in the form that we needed to begin with. In this example, we have a situation where they gave us not just the zeros, but also an extra point. So these values are my zeros, and then we have the additional point there. So the additional point is going to help us calculate our leading coefficient. So with the extra point, we're going to start with y equals a. So we are going to have a leading coefficient here that is an exact value. And then I'm going to put my zeros in. So I've got the x plus 2. I've got the x minus 1, and I've got the x minus 5. Then I'm going to take this additional point and I'm going to plug it in for x and y. So I'm going to put the 24 in for y equals a, and then I'm going to plug the negative 1 in for each of the x's. And now I'm just going to solve for a. So here I'm going to have 24 equals a, and then this is going to give me 1 times negative 2 times negative 6. So this is going to give me 24 equals 12 times a, so a equals 2. So now I can go back to my equation here, y equals 2, and then x plus 2 x minus 1, and x minus 5. So find a cubic function in standard form, so that means we need to go ahead and multiply these out. So I'm going to leave the 2 initially and go ahead and multiply out the rest of it, and then just distribute the 2 at the end. So these first two terms are going to give me x squared plus x minus 2 times x minus 5. I'm going to use the calculator to double check this. I'm going to graph the equation, and then I'm going to check the points that were given to us in the table. So I'm going to go second, trace value, x equals -2, we get y equals 0, x equals -1, we get y equals 24, x equals 1, we get y equals 0, and x equals 5, we get y equals 0. So my table of points is confirmed, and I have my answer.